Welcome to this online course of linear modeling. My name is Sonal Shroff and I'm an assistant professor at the Delft University of Technology. This course is a master's level course which is taught on campus as well as online. All the course information that I will be discussing with you through this video to welcome you to this course is also available on our Brightspace page. Let me start by introducing the course team to you. I am Dr. Sonal Shroff. I studied MSc Aerospace Engineering in Structures and Computational Mechanics at the Delft University of Technology, following which I carried out my PhD, also in aerospace structures, working on the design, analysis, fabrication, and testing of grid-stiffened structures, specifically for fuselage applications. And during this PhD work, as well as during my MSc thesis, I was working intently using numerical methods, and on top of the list was the finite element method. I've learned a lot during my time as a student, both during the MSc and the PhD phases, and also understand the limitations of what finite element methods can and cannot do. Now, using this experience, I now teach linear and nonlinear modeling with the effect of an assistant professor in manufacturing for my research work at the Delft University of Technology. My research interests are in situ consolidation of thermoplastics, so not just process modeling using the finite element method, but also in developing hardware. Now, this is quite an interesting work for me because it comes at a conjunction of many multidisciplinary fields. I have to work with mechatronics engineers, roboticists who also understand how to control these devices so that we can actually make in situ consolidation of thermoplastics work. So if you're interested in carrying out, for example, an MSc thesis after you finish your studies next year, or you would like to apply as an intern within my research group, please feel free to contact me on my email ID, which you will also find on our Brightspace page. I always encourage you to come and have discussions with me if you are interested in process modeling, because manufacturing is a very interesting field which is opening up now. And process modeling in itself is a very unexplored domain. So if you would like to have a future in this field, you can have discussions with me about it if you would like to, and we can work out some MSc thesis projects with companies or in-house at Delft, or also otherwise for online students who are interested in developing this as a field for their companies or for their studies. You're always welcome to discuss this with me, but of course outside the realms of this particular course. Now, I'm not the only one who's involved in this course. I do the lecturing, the organization, and this is basically my course, but I'm always supported by 2 or more people during the course. One of the TAs, who's also working as an online moderator for this course, is Ozan Çelik. He's studied his MSc in mechanical engineering from the Middle East Technical University in Ankara in Turkey. Afterwards, he worked as a design engineer at the Turkish aerospace industries, also in Ankara. And following that, he has started as a PhD candidate within my research group, also working on in situ consolidation of thermoplastics in the process modeling domain. Now, he's interested in the finite element method, as he says, because it's a very powerful tool to solve many kinds of problems, which could be of arbitrary complexity. I mean, you could go from nanoscale structures to very large constructions, and any kind of application is possible as long as, of course, it stays within the multidisciplinary field or multiphysical nature that finite element methods can handle. Now, with the advent of all these very common and simplistic looking software packages that have arrived in the market, these solution techniques have become significantly easier for an end user. So there is definitely an advantage, as he states, or as he thinks it is. However, he also understands that if you do not understand the theory behind this method, you might make inaccurate and unreliable solutions to problems. Therefore, the theoretical background of both the physical problem and the finite element method should be understood. And I completely agree with Ozan's understanding of this subject. And that is the reason why we set up this course, so that you have a flavor of the theory as well as the practical, but also are able to understand how limited this is in certain applications. We also have another TA who's supporting us during the course. Her name is Pishwan Zhao. She's currently following her master's degree at Delft, and she's working on her thesis. Her master thesis is also about simulation of in situ consolidation for tape winding processes. She has an academic interest in thermoplastic composite manufacturing because she thinks or she has a lot of faith in enabling composite materials for shaping it and producing it simultaneously using this technology, but also understands that the part quality isn't at a level of being accepted in the industry. So she would like to find out ways of optimizing the processing windows without doing too many experiments, so that with the use of simulation. So the whole team is very involved with finite element methods. So you can hopefully rest assured that we will be able to help you during the course and we'll be able to answer all your questions. Both the TAs are available through a common email ID, which I will show to you in a few moments in one of these slides here. But this information is also available on the Brightspace page. Now, something about the course setup. Now, as you all would already know, this is a 7-week long course, which means, of course, it's 8 weeks in total, along with 2 weeks of exams, but 7 weeks in terms of providing you with material and lectures. We are going to dedicate 4 hours every week, 2 hours of theory and 2 hours of practical. For the theory, we are going to provide you with a number of videos that will show up in each of the week folders as they will keep on unfolding themselves in terms of modules. We will support these with Hangouts for the online students who are joining us from outside of the Netherlands and outside of Delft. If you are in the Netherlands and in the vicinity and would like to come by to our on-campus classroom lectures, please check the dates and the timings for these lectures and feel free to drop by. I would encourage you to come by and at least see me once, so that if you have any problems in the future or you would really like to be in Delft 1 day a week, we can always arrange that. Along with the videos and the Hangouts, I have also started creating since last year a series of lecture notes. These lecture notes are, of course, still work in progress, so please do not share them anywhere online. I completely trust you not to, but I would like to make this request to you. Please maintain this integrity, because I have not added all the bibliography and units yet, so I need to be sure that it doesn't go published online. Now, on the screen now, you can see these lecture notes. The setup is quite similar to how the course is. However, I do not follow the course, the chapter-wise description from the lecture notes in the course. So I would suggest you to use the lecture notes as a supporting medium to the videos and to the classroom lectures that you would attend, and not the other way around. If you do find mistakes in it, please do not hesitate to send me an email so that I can correct them. There are, of course, a lot of spelling errors, maybe some English editing to be done, and the more help I get from you, the better the quality of the lecture notes can become. Now, the 2 hours of practicals are going to be supported with tutorials as well as exercises. The practical is set up in such a way on campus is that I actually work through a problem with you on a large screen while you follow, and we do a common question and answer round so that everybody can hear what question your peers have and help in answering it. If you cannot get help from your peers, then I would help you answer the questions by showing you and demonstrating you some of the things as well using the software. We will do continuous exercises. So there are 4 exercises, as I will show you later, but these exercises will also be done in the classroom. And for the online students, they will be available also as tutorials or as videos online. So you would be able to follow part of the exercise online. However, at the end of the exercises, you must fill in an exercise results sheet, which is up to you to figure out and answer. This is part of the assessment, which I will talk about in a few minutes. All this information that is given to you via theory and practical will be fed into a couple of assignments. So that is the overall course setup. Now, our goal from the entire course is for you to achieve a strong theoretical understanding of the subject of finite element analysis. You will also get to write your own code in the form of assignments that you are working out. If you do not have any prior experience with programming languages like Python or using MATLAB, then we can help you find some simple tutorials. If you still have no time as an online student to follow this, please do contact us on the TA email ID and we will try to find a solution together. However, I would really encourage you to spend some time on this, as this would really help you build your potential as finite element analysis users, because most of the finite element software these days can be used with add-on user-defined functions which are written with Python coding. We will also work on using commercial software. The commercial software that we provide you support with is either the Simulia software Abacus or the MSc software Patran Nastran. If you are a student who is going to follow the nonlinear modeling course as a follow-up, then I would recommend that you start using Abacus from day one. But if you would still like to use another software, I will not discourage you to do so. Please keep in mind that any other software other than Abacus, Patran Nastran will not be used for tutorials, and hence we cannot provide you with support in terms of the graphical user interface and all the element codes, etc. that you might require. But if you're coming from mechanical engineering or a civil engineering background and you would like to continue using a certain software that you are already well versed with, I'd completely understand, and we will still correct all your assignments when you are using other software. But we will not be able to provide you with any support. What is most important to understand and learn from this course is that there are limitations. When you apply the finite element theory to a certain physical or practical problem, you make assumptions. And when you make assumptions, some of the details can be lost. So we must understand what the limitations are of using this method in physical problems, both in theory and in terms of practice, and how we can apply this within the domain of solving an idealized problem situation. Therefore comes in the topics of verification and validation, which will keep coming up during the course. We will discuss this regularly in the classroom and through the videos. Finally, the part that most of the students would be waiting to hear from me is about the assessment. The assessment will be carried out in a two-stage process. One is in form of exercises and the other is in the form of assignments. There will be 4 exercises in all. They will be released in week 1, week 4, week 5, week 6. There will be 2 assignments which will be released in week 2 and then in week 5. For the exercises, you will work out the tutorials with me in the practicals, and the exercises will be based on those tutorials. You will have one full day, which is of course 5 p.m. till the next working day, to submit your exercise result sheet, which is pre-prepared by me in a Word document. You need to fill in the answers following the instructions, convert it to a PDF and submit it. This will help you get feedback from us about the work that you're doing, but also a maximum of 7.5% of the overall grade per exercise. So if you do everything correctly, you're looking at 7.5 times 4% of your grade already achieved by carrying out practicals with me in the classroom itself. Now, for the online students, I understand that you will not be able to work out the practicals as soon as we release them. So we give you until the weekend to work it out, and you are supposed to submit the PDF by Monday morning, if I'm not mistaken. Please check the Brightspace course information page for further details. All the exercises that I do in the classroom are also recorded, so you will not be missing out on anything. If you do miss out on some questions, please check the discussion board, because the TAs will update regularly all the questions that are discussed in the classroom, both in the theory lectures as well as in the practical, to keep up to date. And if you have any questions, do not hesitate and publish them on the discussion board. Your peers, your TA and myself, we will keep an eye on the discussion board and help answer all the questions. The assignments are going to be released in week 2 and week 5. So that means the first assignment, you will have a chance to solve it within 3 weeks. There will be no intermediate feedback, so we will only check the final submission that appears to us at the due date. Each of the assignments will carry 35% of the final grade. These assignments will be based on material that is taught in the classroom, but slightly more advanced. So you would be able to apply the same knowledge, but probably in a different way. Now, in both cases, I have to specify that you should not be copying or cheating from your peers. Please do not work in groups. This is not a group assignment. This is not a group course. You must all learn independently how to work with these software, with these exercises, with these physical problems, because you're all becoming engineers on your own. If at this time you're not going to spend some time independently working on the problems, then in the future it would be very difficult for you to face these kinds of challenges in your work environment. Of course, all these assignments are open. That means you will be able to access the internet, you'll be able to look up resources, books, references, literature in order to help you solve these problems. So I would recommend you to do that first rather than copying your friend's assignment. All in all, please have some integrity, do your work independently so that we can achieve something out of this course. Finally, some information about the course as to how it is taught. There are no prepared slides. So I basically write everything on this software that I'm using the slides from. These are of course old slides, so I just keep sometimes repeating them and changing them. There are no open office hours at all. So if you're an on-campus student, you are not allowed to drop by our offices even if you know where we live. First point of contact will be the discussion forum. If we do not answer you in the discussion forum and it's extremely important, then send as a second resort an email to the TA email ID. And as a third resort, send it to me. However, I will only react to issues that are extremely personal and you do not want the TA to have a look at them. So please get to the discussion forum, keep the discussions open. The idea of using the discussion forum is so that it's not just you answering us questions, but it's also to stimulate you and your peers to have a discussion among each other. Don't forget that there are a number of online students who are coming from very different backgrounds. A lot of them, or most of them, also have work experience and can help you understand real-life physical problems. So if you put your questions out there and request them to discuss these problems with you, it would be very useful for you to learn from them and useful for them also to get a more of a community and a classroom feeling despite being a purely online student. So the idea of a discussion forum is not just to have Q&A, but also to engage in meaningful discussions about a certain topic. And of course, by a certain topic, I mean it should be related to the finite element method, the assignments, the exercises, the software, so that we keep it limited to the topics that we are here to learn. Thank you very much, and I hope to see you in the classroom. Before you come to the classroom, please do not forget to read through the course information, install all the necessary software on your systems, take a survey for which software you are going to use, and finally, for online students, take the surveys that are posted regularly for you. It helps us improve the course for you. It helps us understand what your expectations are, not just at the end of the course, also at the beginning of the course, so that we can alter it and design it according to your needs. Thank you very much and hope to see you soon.